So, hi everyone. I'm James Yarrow. I'm a software engineer with the Xbox Advanced Technology Group, and this presentation here is how Microsoft gets the most out of games with UWP. So this is kind of a follow-on from this afternoon's State of Play, gaming on UWP session. So if you attended that, great. You'll have seen some of this before. If you didn't, here's a quick recap. UWP is a gaming platform. The games are here. You can see them. We've got games. We've got the middleware that underpins them, and we're doing more. We're bringing the Xbox Live Creators Program, which is opening up console development like never before, and we're adding new Windows features like game mode that enable you to get even more out of your hardware, out of your game. And so, having talked about all that, what I wanted to do for this session was kind of grab bag a smattering of topics that I've found are of interest to me or to other developers in the hallways as we work on bringing big games I've worked on like Quantum Break, or upcoming games like Crackdown 3 or State of Decay 2. What's interesting to us? What matters to us about UWP? What, in 20 minutes, do I want this audience to know? So it's this sort of, we're going to go all over the place, but let's start. And let's start with the big one. Let's start with performance. Everybody wants to know about performance. It's a new game platform. Is it fast? Is it slow? Well, the games you saw, a lot of them are big games. They run properly on UWP. It's not a slow platform. It's a fast platform because it's a PC platform on PC. It's the same hardware underpinning it. It's the same code. It's running the same way. You hear a lot of people talking about UWP sandboxes, things like that. I don't want you to be scared. There's no virtual machine that is slowing your code down. Your lightning fast hand optimized native code is lightning fast hand optimized native code on UWP. And so we hear a lot of fear. Don't hold on to the fear. Let the fear go. It's better than that, because you can take advantage now of game mode with the Creators Update. Game mode is something you can request by default in a UWP app, and when you are in game mode, you've potentially got cores that are dedicated to your game process. So it's not just you've got the same PC you always had. Maybe you have even better access to that same PC that you always had. So again, key points about performance. Don't be afraid. Now, that said, some of your interactions with the OS are going to be different on UWP. Mostly, those live outside of your core game loop. They're not things that need to happen at 60 hertz. And so you're less worried about, is the performance the same? Is the performance different? Once you pass kind of all that core startup, that stuff's really out of the way. Well, that's not necessarily true of D3D, right? D3D is pretty important that performs well continuously all the way through. And the good news is, it's the same. It's the same with this exception. Your output is not in your control in the same way that you might be used to if you were developing a full-screen, exclusive Win32 app where you could go change the mode. You can't do that in UWP. Your output is driven by your window resolution, and your window resolution is in the hands of the user. You can ask for it to change size. If you're in windowed mode, it might work. But the user can always change the size themselves by pulling those borders around. And if you're in full screen mode and you ask to change the size, well, that's not happening. Because you're not really in full screen, you're a full screen window. You're at the desktop resolution. So what I want you guys to take away from this first point about performance, besides, on the CPU it's just as fast, if not faster, is separate the resolution at which you actually do your drawing from the resolution that the OS tells you your window is at. You can do that. You can ask for a different size swap chain from Direct3D than the actual window resolution. You won't see that necessarily in a lot of samples, but it is definitely something you should do. And by default, what you'll get when you do that is you'll get stretch scaling. The XGI scaling stretch, that is the default behavior of your swap chain when you present it a different size from the native size of the window. For games, you're probably not going to want that, because if you window some weird size, but you're rendering in a nice 16:9 ratio, you're going to get all sorts of mess. The XGI scaling aspect ratio stretch is going to be your friend here. And the last thing I want to say about this scaling point is, when you are running on a device where you've got a hardware scaler available, this is going to be free, basically. You're not going to see this coming out of your GPU time. That's going to be running through this hardware scaler. So I'm thinking, for instance, about an Xbox One. If you're on a device where there's no hardware scaler available, then you are paying some time for this scaling, even though it's done by the system on your behalf. And so one area where I want people to watch out, and where there is really a case for different performance on UWP to Win32, is thinking about mobile devices with high DPI screens. And so you are going to want to be careful in that area. Moving on, I'm going to stick with performance a little bit, but change a little from GPU, maybe for that last point, to CPU. I talked this afternoon, for those of you who are here, about how vast majority of the Win32 API that games care about comes straight across from Win32 to UWP, which is great news. But here's one that doesn't. Set thread affinity mask is not there. The reason is it's been replaced with something better. There's the new CPU set APIs. So, set thread affinity mask, you may be using it to bind certain threads in your game to specific cores, right? You're separating your game logic and your render, you're putting your audio somewhere dedicated so you don't get dropouts, whatever it is. Well, as you port to UWP, you're going to need to switch to these new APIs. So you've got get system CPU set information, which tells you a bit about what's available in the box. And then you've got set process default CPU sets, which allows you to control where your threads land in the absence of any other information. And then finally, you've got this set thread selected CPU sets, which is pretty similar to the old set thread affinity mask. Now, I said it's better. Why is it better? Well, I think it's better because a lot of the information that comes back from this new get system CPU set information is information that was kind of hard to parse out in the old version. Information like, do these logical processes share a physical core? Do these logical processes share a top-level cache? These things are really important and interesting when you're trying to work out where to park your threads, right? You don't want heavyweight threads sitting on two logical processes that are actually on the same physical core, but you do want threads that share data to sit on logical processes that share a cache. That's a lot easier to get out of the new version, again, in my opinion, than it is from, say, the old one. But it's not just my opinion that it's easier information. There's new stuff in this one that interacts with game mode. There's this new flag that'll come back in the CPU set information you get back, allocated to target process. That lights up when your game is running in game mode, and it can tell you which of the processes in the system are the ones that game mode is allocating for exclusive use by your game process. And so this is one of these cases where you can use these new APIs and the new capabilities of UWP, game mode by default, to actually get more out of the system by carefully picking which cores you are binding your threads to. I've got the other game mode APIs up on there for reference too. Those almost certainly participate in some of that high-level core selection logic that you're going to do. There's a great talk that we gave at GDC. One of my colleagues from the Advanced Technology Group delivered a talk on game mode, and I highly recommend you guys go view that talk to learn more about game mode and CPU sets. Flipping a bit, moving off performance, thinking a bit about concepts that are relevant to a game at runtime. And what I want to highlight here is one that comes up a lot. Again, I'm specifically Quantum Break or State of Decay 2. These are projects where this concern has aired, and that is around content. Games are typically very content-heavy applications. And you've got all those textures, all those meshes, all that level data, whatever it is, content-heavy, right? And the file access restrictions that are in place on UWP mean that content needs to land inside your app package, or else your app isn't going to be able to get at it. Now, if you're running on a middleware game engine, and that was something I talked about a bit earlier this afternoon, again, I refer you to the State of Play talk, that's a great choice. Your engine will almost certainly help out here. But if you're on something custom, and you're thinking about your F5 developer iteration scenario, you're running out of Visual Studio, you probably don't have your content participating in the deploy step that's going on there. So one thing you might want to look at is, well, should it? Maybe it should. Maybe you need to bring your content into that deploy. Another solution is pretty common, common in desktop games too, because it actually offers a way to deal with differences in content formatting between source and runtime, is to run a Win32 process, acts as a file server, operates over a socket connection. UWP starts up, connects to that, pulls all the content in a streaming fashion across that. Again, this is actually built into some engines that you can get off the shelf. I want to call out with that it does absolutely work in UWP. That is certainly an approach you should consider, but there are some things you need to look out for. You need your capabilities to flag you as supporting network access on whatever level of network you're operating on. Even if you're not doing multiplayer, if you're going to do the streaming file server, you want the network access capabilities. I've got them up on the slide. You're also going to want to look out for one of these other UWP restrictions, which is that by default, a UWP app cannot communicate over a socket with a server that is running on the same box. You're not allowed to talk over loopback. Luckily, it's easy to opt out as a developer. In fact, it's so easy, Visual Studio does it by default these days. When you hit F5 in Visual Studio, you got default settings, you're opting out of that network isolation, the loopback restriction. But if you need to do it manually for whatever reason, maybe you're operating outside of a Visual Studio scenario here, but you still want to use that network file server, you're going to use this check net isolation utility. This is part of Windows, so you all will have it. And that version there will add a loopback restriction for this scenario of connecting to a server, where PFN here is your package family name for your UWP app. There's a flip side to some of this network communication, which is that occasionally your app wants to act as a server and you have some tool that you want to connect up to it. Maybe a middleware profiler or debugger or something like that that operates, again, over a socket connection. Well, in that case, your loopback restriction will affect you here too. And the best advice I have for you today is to make sure that your UWP that you are trying to connect to, operating as the server, and your tool that you are trying to connect with, that those are on separate machines. And then it'll all just light up. But you're going to have to separate them at the moment. Changing tacks completely again, I told you this was kind of a grab bag. I want to talk, kind of for my last point, about the runtime user experience of a UWP game. The point I want to land here is that while the platform is universal, you can take one package and run it on a whole host of devices, the experience doesn't have to be, and it probably shouldn't be. A UWP game on PC is still a PC game. This is strong feedback we've had in response to our UWP releases. PC gamers appreciate when games like Gears of War put in features appropriate for a PC audience. And I've got kind of a list here of some things that come up, you know. On a PC, you might have multiple graphics adapters. Make sure for your game you're running on the discrete one. You want to make sure that the user has customization options. I talked earlier about being able to change your output resolution, so it's not necessarily the same as the window resolution. Well, some of that should, of course, be in the user's hands so that they can select the right balance between performance and quality, and all the other quality settings that you'd normally have in a PC game. You might have exotic hardware attached to your PC that you're running on, and gamers have invested in this hardware. They want to show it off. Let them use their ultra-wide monitors. Let them use their exotic input devices. On the other hand, when you come to Xbox, you've got a much more contained hardware environment, and your focus wants to be on a great couch experience. Game controller probably is the focus, although as we spoke about this afternoon, keyboard is also a possibility with UWP. One thing that's really different about the Xbox to other devices in the Universal family is that it supports multiple users interacting with the console at the same time, right? If you think about a Windows device, each user has their own session. Or a phone, there's just one user. But an Xbox, you can go sign in 4 users, and they can all be playing. Well, if you want to do that on UWP, and you want couch multiplayer in your Xbox game, that's something that matters to you, you need to make sure that you flag yourself as supporting it. Otherwise, you default to a single user scenario, just like every other device in the family. It's a line in the manifest. It goes in the properties section. I've got it up here. And you should carefully consider whether it is appropriate for your game. It does incur extra work because you now have to handle users arriving, users leaving, which you wouldn't before. But it also gives you new options and new ways for your users to play. So again, it's really about designing the experience that fits the device. And that is getting to be just about all I have time for. So I'm going to wrap up with really just a single link here, because this is the hub for all the UWP game development material that lots of teams at Microsoft have been putting together. Now, this is your one-stop shop that'll take you to lots and lots of different information that'll help you learn more about some of the things that I've talked about today and some of the things that I talked about earlier this afternoon. And with that, I'm going to yield the stage, and I'll probably hang around to the side here, and we'll take your questions offline if you have any. Thanks very much.